Now we're going to look at multiplying mixed numbers using an area model, part 2. And the beginning of our process is going to be very similar to what we did yesterday, in that we are going to draw our area model out, okay? And remember, going horizontally, we have each square representing 1/3 because our fraction is in thirds. And going vertically, up and down, each square represents 1/4 because our second fraction is 2 and has a denominator of 4, 2 and 1/4. So let's quickly do that. So here we have 1, 2, 3. 3/3 represents 1. 6/3 represents 2. 9/3 represents 3. And we need to go 2/3 more. So that's 3 and 2/3. Okay. So 3 and 2/3. And for the other fraction, we're going to go down and we're going to represent 2 and 1/4, counting 4/4 to make 1. So 1, 2, 3, 4. That makes 1. 8 makes 2 wholes, and another 4th makes 2 and 1/4. 2 plus 1/4. And just like we did yesterday, we're going to complete the rectangle since we are using an area model. Okay, rectangle complete. Now here's where we're going to get a little different, in that instead of counting just the number of tiles in the area of each individual tile, we're going to look at more of a place value model. And what I mean by that is we're going to take a number like 3 and 2/3 and consider the 3 to be the whole number place and the 2/3 to be the fractional place value. And with 2 and 1/4, we're going to look at 2 as the whole number place and 1/4 as the fractional part of that. So let's take that into consideration and draw a line across here, because this represents 2 as a whole number and 1/4. So we've divided it into the two place values. And if we draw a line down here, this section represents the 3 and this section represents the 2/3. Now if we want to know the total area of the rectangle, all we have to do is calculate the individual area of each size, each piece, and then combine them together, and that will give us the area of the rectangle. And that will also give us the answer to the multiplication problem. So the first area that we're going to be looking at is this big one, and it is 1, 2 by 1, 2, 3, which gives us a total area of 6. Okay, because 3 times 2 is 6. And let's go right over here, the one next to it. Now we're looking at an area that is 2 by 2/3. So 2 can be written as a fraction as 2/1. And 2/3 is what we're multiplying it by. And we get an answer of 4/3. But I'm going to simplify that a little bit, and I'm going to say that is 1 and 1/3. Okay, because there's my 3/3, and one more makes 4/3, so that is an equivalent representation. Okay, now I'm going to switch down to this lower area right here, which is 1/4 by 1, 2, 3. And again, if I multiply that out, I can write 3 as a fraction, 3/1, times 1/4, and that gives me an answer of 3/4. So let's put that down here, 3/4. And lastly, to get this tiny area here, this is 1/4 high by 2/3 across, and 1/4 times 2/3 is equal to 2/12. Okay, and let's do that, 2/12. Now some of you might be saying I could simplify that into 1/6. Yes, I could, but you're going to see in a moment why I don't want to do that right now. Okay? Okay, so I've simplified this drawing a little bit because for this method, it's really not as critical that you use the gridded paper. What's critical is that you draw the 4 boxes and that you realize, what each box is representing. So here we have 6 because it's 3 by 2 or 2 by 3. 2/3 times 2 is 1 1/3. 1/4 times 2/3. That'll go right here, and that's 2/12. And then 1/4 times 3, and that's 3/4. So same answers we had before, just simplifying and cleaning up the drawing a little bit. And again, if we just add these across, and the total of all 4, then we'll have the answer to our problem, which I probably should rewrite up here, 3 2/3 times 2 1/4. Okay, so I'm going to add 6 plus 1 1/3 plus 0 3/4, and I'm not just using that 0 as a place value holder, so I know there are no whole numbers in that one, and 0 2/12. Now, a moment ago I said I don't want to change 2/12 into 1/6, and here's the reason why. As you go to add up these fractional parts, you're going to notice you've got 3 fractions, and all 3 fractions have different denominators, so that kind of presents a challenge sometime. However, the nice thing about this method is you will always find your common denominator in this box if you don't reduce. So the common denominator between 3, 4, and 12 is 12. So let's go ahead and change those fractions. 1/3 times 4/4, because 4/4 is 1, so I'm just multiplying a number by 1 to get the same result, just a different form, and that's 4/12. So here I would change the 1/3, and I would say this is 4/12. 3/4 times 3/3, because 4 times 3 is going to give me my 12 denominator that I want, and 3 makes this number 1, 3/3, so I'm multiplying by 1, and I get 9/12, so that's going to be an equivalent fraction, and 2/12 is already there, so I don't have to mess with that at all. Now all I got to do is add up those 3 fractions. Okay, so over here I have 4 plus 9 is 13, so I get 15/12, and I add up my whole numbers, and I get 7. So I get 7 15/12, but that 15/12 is an improper fraction, so I'm going to take 1 whole out of there, and that leaves me with 3/12. So I take the whole and I carry it over to the whole place value. Okay, so 7 plus 1 equals 8, and it was 8 3/12. Now if I choose to, I can go ahead and reduce the 3/12, because that is equal to, if I take 3/12 and divide that by 3/3, this 3 goes into both 3 and 12, I get 1/4. My final answer is 8 1/4. So let me do one more example rather quickly to kind of bring this together. Notice that I'm not using the grid. My box is not proportional, but all I need to do is use these 4 boxes to know that I have 4 different numbers that need to be multiplied together. And I need to decompose or take each of these numbers and put them into their place value parts. So I'm going to look at the whole number part, which is 11, and the fractional part, which is 3/4. So there's my first number. And I'm going to look at the whole number part, which is 7, and the fractional part, which is 2/5. Okay, and then I just need to calculate and write down the area of each individual box, and then I'll add those 4 boxes together, and that'll give you my answer to the problem as well as the area of that rectangle. Okay, so 7 times 11 is 77. 7 times 3/4, remember that's 7/1 times 3/4, okay, 21/4. And again, I want to convert that into a mixed number because it's just going to make it easier when I do the multiplying later. 21/4, that's 24 goes into 21 5 times, and there's 1 left over. 2/5 times 11, that's 11 over 1, times 2 over 5, that's 22 over 5. And again, 5 goes into 20 4 times. There are 2 left over, 2/5. And lastly, I get 3/4 times 2/5. 3 times 2 is 6. 4 times 5 is 20. Remember, I don't want to reduce that one because I'm going to use that as my common denominator. Okay, now all I got to do is add those 4 pieces up. So again, looking at place value, there's a whole number of 77. There's 5 and a fractional part, 4 and a fractional part, 0 as a whole number and a fractional part. And so I need again to have my common denominator, which I know is going to be 20, because I'm going to get it right here. Okay, and 1/4 times 5 over 5, that gives me 20 as my denominator, and 5 as my numerator. 2/5 times 4 over 4, that gives me 20 as my denominator, and 8 as my numerator, and 6/20 is already in 20ths. Okay, so let's add this up, do the fractional part first. 5 plus 8 is 13, and 13 plus 6 is 19. Okay, that's a good deal. I don't have anything I need to carry over, so I can just add up my whole number column. 7 plus 5 is 12, plus 4 is 16. Bring 1 over, 10 over actually. Okay, so 1 plus 7 in the tens column gives me 8, and my answer is 86 and 19/20. Hope that's understandable. If not, go back and take a look at some of the parts of the video, slow it down, replay it, whatever you need to do, but hopefully that will help you.